Good afternoon. So this is a session on data visualization, and I am Pramod Jain from Spinspire out of Jacksonville, and we do a variety of consulting, primarily in the enterprise space, and this is a service that we created for a renewable energy client. So this is a wind energy client that wanted to visualize a whole bunch of data. And just to let you know, we're a small company. We are hiring. We're looking for Drupal people, entry-level Drupal people. So see me after the session if you're interested. Okay, the next. So let me talk about, just as an introduction, what the old paradigm was. Is basically, you would send data to a server. It would create a raster image, PNG, GIF, JPEG, send it back to the browser, and then you would see the image. Right? And I call that sort of a dead image paradigm. Okay. So, which is the image you got was not really interactive. You got what you sent back, and every time you would have to make a trip to the server to change anything. The new paradigm, obviously the latest one is HTML5 with Canvas or SVG, Scalable Vector Graphics. And what I'm going to focus on is SVG, and that's the paradigm that we use. I guess how many of you heard of SVG, used SVG? Oh, cool. Cool. All right, that's good. So, as you all know, it is vector-based. We are, giving instructions based on vector points, and not really drawing out the bitmaps. The advantages obviously are, it's all happening at the browser level. You can manipulate the DOM. You can quickly redraw stuff by sending instructions by JavaScript. All right. A quick background on our visualization needs. We're looking at wind measurements, and all this happens before a wind project gets put in. These are wind farms, these are wind turbines generating energy. So you put up a 60-meter, 80-meter met mast where you have instruments that are measuring wind speed. And typically you have about 10 to 15 instruments. So you have what are called anemometers, which measure wind speed. And there are usually two of them on two sides of the tower. At 3 levels, you're measuring wind direction, you're measuring temperature, you're measuring solar radiation, measuring all kinds of stuff, right? So all that data basically goes to a data logger that's right on the tower, at the base of the tower. And then at the end of the day, all this data gets kind of assembled and then sent by email, but sent by a wireless modem to us as an email. And this is data that's captured every second, sent to the data logger. The data logger kind of keeps it in memory and then writes the data every 10 minutes. Okay, so it's writing average standard deviation, min-max of wind speed, for instance. And that's the file we get. We get a 10-minute file. So a file that has 10-minute measurements. Okay. So we take this file, put it into a database every day, and then we are plotting it. As you can imagine, this is a lot of data for anybody to visualize and make sense of, unless you use something like this. So that's the motivation of the project. Obviously, there's a lot of aggregation going on, and then correlations between different data series. Okay, and so the challenge we faced was which data visualization tool. And we clearly did not want dead images, which is sending it off to the server and the server returns a bitmap to us. We wanted live charts, interactive, and so on. Wanted ability to create custom charts. And I'll show you some custom charts we've created. Wanted a scalable solution. And if you've used some of the PNG tools or GIF tools, or the ones that we were using, actually Google had one of those services where the entire data set would go on a URL. It goes to the server and then the image comes back. And obviously you can see the limitations of just, you can't send a lot of data. And then we didn't want to make multiple trips to the server. So vector graphics was a good choice. And further Google chart tools, good stuff, well documented, works, stable. So we went with Google chart tools. So what is Google chart tools? Completely SVG based charting. They provide a JavaScript API. And I've said this multiple times, data is processed, rendered by the browser. It's not going to somebody else's server. None of that is happening. Decent selection of chart types. You can also render data through the API instead of us having to manually do anything. We can render the data along with the chart, do multiple charts on the same page, interactive charts, good stuff. All right, let's do a quick demonstration. And I just saw my internet went down. Okay, so this is kind of what the site looks like. We have data up till yesterday. This is a line chart, and let me change. We're looking at daily data. If I change it to raw data, you're going to see a lot of things like that. And then I don't want to enter a date. Let's just do it anyway. Start on February 1st. We won't specify an end date. Apply. And this gives me, again, a lot of points. Decent line chart. The other type of chart, thank you, is a what's called a polar chart, and this is we're drawing in the polar axis instead of x and y. This is basically angle and then the magnitude. Okay. I didn't do anything.
Strong idea.
Okay. So this is a chart that we wanted to draw, and just to give you some meaning, I mean, just for fun, just to see what it is. What this is telling us is north. How much? Sorry. What is the what is the average wind speed that's coming from the north? The blue point, for instance. And then the red is what is the frequency of wind that comes from the north. So, for instance, you may have the average wind speed may be very high, but if you don't see that kind of wind often, obviously it doesn't have enough energy and so on. So this is used to orient wind farms and to get, if you have wind turbines in multiple rows, you want to reduce the wake of turbines in the back. So all this data is used for that kind of stuff. So this is a very neat chart that we had to draw for this application. And the next one is a pretty simple one, which is a frequency chart. And this is just saying that wind speeds between 10 and 11 meters per second happen, whatever. It would have been better if we had made it percentages, but 674 times we've seen wind speeds in this range. All right. So those are the chart. Well, I didn't show you the data. So we also plot, or we also draw the table with the data with it. Okay. Now let me show you some of the SVG code and how Google does SVG on this. So okay. So essentially, to the chart, to the charting software, to Google, we specify a container, and I'm looking for the container ID. I don't see it here. It's probably hidden somewhere. So there is a container ID in which this SVG gets placed. SVG along with some of this stuff, edit chart from here on. And if you haven't seen SVG before, this is what sort of vector specification looks like, saying draw a rectangle starting from x0, y0, width, height, stroke, all the good stuff. And G is a grouping. This is all sort of, you're drawing the periphery of the chart. This is also the periphery. Okay, the actual chart is a path, which is you're drawing this line, right? This blue line that goes up and down. So that's a path, and that's what it looks like. It says move the cursor to this x, this y, and then now I forget what C is. And again, we don't have to write all this. Google chart creates this, and then I think it says connect to the next x, the next y, and da, 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 da. It just does the long chain of x, y points. Okay. All right. So give you a quick background first of how does what do you do with Google Charts. So I'll start out with the JavaScript part. What do you write in JavaScript? And then we'll sort of link it up to Drupal. So what Google provides is a JavaScript API. The first call you make is to load the API, and that's the visualization library. And in this, there is a second part where you load packages. So you're loading, drawing chord chart. Chord charts are basically pie charts, line graphs, and so on. And table is to actually draw the tables. So you're loading all your packages. After the library is finished, you basically ask Google to call this function DrawChart after the page is loaded. So onload callback, and then DrawChart is where you do all your activities. So you create a data object, populate the data object with data options and so on, and then you call it to draw. So this is what it looks like. This is what a JavaScript code would look like. This is the DrawChart part of it. Creating a data object, adding a column. You just at this point just specifying what the columns are and the column titles, and then the row is your array of data that goes into this data object. Specify a bunch of objects, a bunch of options, and then this is your call to the line chart. So you call a line chart class, and you're inserting it into this development in the HTML, and then you call a method on chart to draw with this data and with these options. Okay? So nice clean API. Okay. Now let's go through how it's done in Google in a Drupal module. So this is the Drupal module. It's called Google Chart Tools. That's the name of the module. Very simple, short. Just loading the JS API, add JS. This is the function that my module will call. So we'll write all the data handling modules, all the database calls. Once we've created this object settings, we call Google Chart Tools DrawChart function. So again, as opposed to a lot of modules where you have configurations and most of the stuff is done through configuration, here you actually have to write code. So you write code and essentially you call, from your code you call DrawChart settings. And settings contains the data, settings contains your options, chart options. This is just some simple stuff. We add a CSS. This is again part of Google Chart Tools. We add the JS file. We are injecting our Drupal variable, so it's available in JavaScript. So this is the entire data set, the data set and options. So that's basically what's going on in this module. Here is the JavaScript file that Google Chart Tools provides. Again, starts out with the calling of the API. This is our standard Drupal way of putting JavaScript in it. Again, we talked about set, on, load, callback, DrawChart. DrawChart is called. We're creating a data object. And in this case, we are loading a core chart package, a gauge package, just a chart which is a gauge, org chart. It allows you to draw an org chart and tables. So those are the packages we are loading. All right. So again, this comes with the module, Google. And in our case, we to create a custom chart, we added some code here, and I'll go through that code a little later. Okay. Just to finish the picture on what else we had to do, as I mentioned, emails come in every day. So we had to write a program in Windows, and the issue was the manufacturer of the data logger provides a DLL that you have to run to go into your email box and extract the attachment. Okay, and it was available only in Windows. So we have a VB script program that checks emails every day, extracts the attachment, puts it in a folder, and then we take that file and sort of SCP it over to a Linux box. And then we run right from Windows. We run a shell script program in Linux to actually move all that data into MySQL. Okay, so that's kind of going on in the background.
Don't mind me making the video better. Sorry.
All right, I'll stay. Okay. And the shell script got pretty tricky because the header of the file contains a lot of metadata about sensors and what kind of sensor it is, what are the ranges, all that stuff. And then it comes down to the data. So you have to parse through all that and get to the data. then import it into MySQL. So anyway, so this is all happening in the background, and nothing to do with Drupal. Then we had a choice of actually taking this data and creating a table within the Drupal schema, and we said, nah, let's just keep it outside. So we created a new schema which contains only Win data, because pretty soon this data gets really large, and for archiving and for a variety of purposes, we said no, we are going to keep it separate. And then we created a custom module called Win Data. Use the Forms API to do a lot of selection options and so on. Data abstraction layer to get the data out of the database. And then we've added tooltips. So as you hover over the chart, it tells you what you're looking at, gives you the numbers, and I'll show that to you. And then we added a table at the bottom of the chart. So this is kind of what we've done with the API. And now let me show you how it looks on this. So through Forms API, we basically create this, which is you could be getting data from multiple sites. So this is where you're choosing a site, choosing the type of chart you want to draw, choosing the type of aggregation of data that you want to see. And then there are chart settings for width, height, chart title, x-axis settings, start date, end date, label, y-axis is the key, where we have data that's coming in from channel 1, it's the average wind speed. There is channel 1 standard deviation of wind speed, channel 2, channel 3. There are 15 channels of data that come in, and we can plot multiple channels of data. Choose. So I'm just picking some randomly. I don't want to draw raw. Let's do daily, apply. And it's sort of drawing those channels, data from those channels. So this was obviously done through Forms API, and the chart tooltips basically show up as this is my X point, which is the date, and then the Y point is 8.76 meters per second, channel to average wind speed. So that's again a tooltip that's part of the data that's supplied to the chart.
Are all your standard deviation and averages, are all of those already worked out, or when you just did that, is it solving for those and plotting them right now?
It is solving for them. So the database contains basically raw data.
Okay.
And then it's basically in SQL, in Select, we do our computations.
I'm confused by one point. You said that none of the data goes to a Google server. Is all the data being done client side here in JavaScript? So I have to expose all my data to the client?
Correct. You have to expose
So
it to the client.
conceivably, a malicious user could steal all your data.
Correct.
So you have to have trusted users.
Correct. So you can go into inspect element and Drupal.settings, Drupal.setting, and it'll just give you all the data. You can print all the data.
Yeah, but an end user can't get to it. I mean,
I'm sorry?
An end user can't get to it. Someone who's just on the browser wouldn't be able to connect to it. I mean, it's still.
No, if you had an account, I mean it's password protected, but if you had an account, you could get to it.
Right, but someone going, what I'm saying is someone who's just a user of your data couldn't just suddenly get access to the raw data. To get raw data, you need to be a user of someone that you've trusted with
Well,
access.
it sounds like anybody that could view these charts could have access to the data.
No, you have to be, I think you have to be a user that he's authorized to give you permission to go in and look at it.
No. Anybody who's looking at the charts, basically that whole data set is exposed through, Drupal settings, Drupal.settings, I think it is, and then you could go in and say, for instance, raw, and raw data would basically show up as an array, and you would see the data to inspect element. Yeah. So this is basically provided to owners of the data. I mean, those are the people that want to see it. So this is intended for them. We've seen the options. We've seen the tooltip. Custom chart. The data that Google uses is they assume the x-axis is a string, and so it's basically categories, and then y-axis are numbers, right? So they plot it out. So in our case, what we needed was the x-axis to be a number as well. When we draw these polar charts, we have both x and y as numbers. And again, they provide a way of doing that. The other thing we needed, obviously when you draw a custom chart, or in this case a custom chart, you need to be able to draw, we needed the ability to draw circles. So let me show you what I mean. Like this. We want to be able to draw these circles, we want to be able to draw these lines, right, in the background. So the chart makes sense, so somebody looking at it can see this, and then be able to draw all these labels, northeast, 3, 4, and all that stuff. So this was an interesting exercise in SVG. So what we do is basically use, since all this is being done in SVG, we created a custom module which adds SVG elements. Okay, so we created in settings itself. We create, for instance, an array circle, and then we specify the attribute. CX is the center of the circle, X center, Y, the radius, scale, stroke, all this good stuff. Okay. Okay. So the way we do it is Google sort of returns a SVG chart, and then it provides listeners. So once the chart is ready, means the chart is plotted, then we essentially call an event. We trigger an event, which then goes in and says, okay, now I'm going to go to the bottom of this SVG SVG and start inserting new SVG elements, right, which draws the circles and all that stuff. So that's basically how we did this stuff. And let me show you the code that does this. Okay. So the first thing is we create a trigger. So a trigger says when this, whatever, when the chart is ready, okay, I want you to call before draw, and I haven't pulled in, and I'll talk about this in a second. That is So this is and basically to my container, I bind this function, this trigger function. So when this is triggered, it basically calls this function, and then this function I'm adding a listener. So when the chart is ready, I want you to run this function. And what this function does is basically goes through my object that I've created in PHP, and it picks out the SVG elements. It picks out the circle, it picks out the lines, and picks out the text, and creates an SVG element out of it and inserts it into the DOM. So again, if you guys are interested in this, I'll share this code. Other things that are possible with with Google Chart tools are it provides a variety of charts. Obviously, the simple ones we know: pie, scatter, gauge. But this is interesting: geocharts. And we haven't played with it, but it's pretty fascinating. That on maps, you associate data and show them. And then just a whole variety of charts, combo charts. Where is the combo chart? This one, bar chart and a line chart, and then other kinds of things like candlestick and so on. The other thing it provides is the ability to do animation, and so it lets you do stuff like this. You can see a data move, for instance. So one of the things that I'm going to do next, and we've made some progress towards it, but I don't have anything to show, is to be able to kind of scroll the data. So this is showing a window of 30 days, something like that. No, 10 days. And I would like to be able to scroll it. So, and what we want to do is get data either through Ajax and so on. And as soon as we insert it into a row, basically that's all you need. You got to be able you define a transition or an animation on row insertion, and as soon as you put this data into a row in JavaScript, Google then just does the animation. Okay. So that's something we want to do. In addition to just something that would look neat is sort of show how the direction of wind and this wind speed and wind direction changes every month. So we could draw this for January, it would look like this. February, it might turn. March, it would turn, and so on. So be able to see data in action. So some really cool stuff that we can do. The other thing it allows you to do is a standard toolbar where you can download the data in CSV or a HTML table. Oops. Okay. So that's basically all I had. So open up to questions.
How's the browser support for the Google API? Does it work on every browser or only on Chrome?
I was really surprised. I tried it on IE8 and it works fine. IE9. I haven't gone below IE8. So really surprised.
Safari on an iPad or
we've tried it on iPad. It looks fine.
Even, you know, on like phones and stuff, sometimes if you're like doing all those calculations, is it still run all right? I mean,
We haven't tried it on a phone. I haven't tried it on a phone.
Why did you go?
I need to
with-
be adventurous for that. Sorry.
Why did you look at PHP side libraries? Why did you go with the client side library? Was it just the easy choice?
Yeah, just the interactivity and you know, be able to you know, get
But you didn't
Live.
really look at other
at
libraries? I'm just
PHP.
curious.
No.
Okay.
At server side libraries, no.
So I wasn't unsure. Are you copying the code and putting it into your public HTML or into your server, or are you downloading a module and then opening that module and messing around? So I wasn't sure if you downloaded or.
You mean
downloaded
Google
module.
Chart Tools module?
Yeah.
How do we use it?
Yeah, like what are the beginning steps? I guess once you got the module, like what
Right. So we
are you
basically
adding are you adding more stuff into it? And,
no. So you write your own module, a custom module,
okay.
which basically is dependent on Google Chart Tools. So when you enable your module, if Google Chart Tools is not there, it's going to download and all that stuff, right? And then you write your module as if you were writing any other module. Form API, making all the database calls, and the purpose of all that is to construct your data structure, right? That Google Chart Tools can then take, because I'm going to call DrawChart in Google Chart Tools module, which then takes all that and essentially inserts that whole data structure into JavaScript. And then the Google JavaScript API is able to access all the data and create a SVG out of it. So that's kind of the process. Any other questions? Thank you.